Hi. So this is the last section in chapter 3 on solving conversion problems. And we are going to learn a technique called dimensional analysis. And we will use this technique for almost all of our chemical problem solving this entire year. So we're going to sort of start from the beginning, learn the technique, apply it to real simple conversions that you probably already know how to do, and then eventually we will use this technique to do some conversions that don't even necessarily look like conversions. We will use this a lot in a chapter that we call stoichiometry in a few months from now. So we're looking at just the first learning objective in this video. Explain what happens when a measurement is multiplied by a conversion factor. So here is two problems, no math at all, no numbers, but they're called dimensional analysis warm-up. And here we're just looking at using pictures in order to help us understand the math of what's going on a little bit. So you can see in the first problem, we have this orange circle out front. It's being multiplied by a blue square over an orange circle. And then that's being multiplied by a yellow triangle over a blue square. And now you probably remember from math class that if you have something on the top and on the bottom of a fraction that is the same, then those get to cancel out. So just as, if you have 3x over x, the x's get to cancel out. Or if you have 3x over 3, the 3's cancel out. So anything that doesn't have a denominator, we can put it over 1. And then this circle and that circle would cancel, and the square would cancel. So the only thing on the left-hand side that remains is that yellow triangle. That's my answer. This number 2, a little bit longer one, and you can see the exact same thing happens, right? Here's my red stop sign in the numerator. That cancels out with the red stop sign in the denominator. It doesn't matter that they're not right next to each other. One's in the denominator, one's in the numerator, they cancel out. The stars cancel. So what is left? A heart in the numerator and a lightning bolt in the denominator. Questions 3 and 4 are the same, except they're asking you now to solve for the question mark. So hit pause, answer what you think the question marks would be, and then restart again to check your work. Okay, so in the number 3, this symbol and that symbol cancel. The black diamonds cancel, and so what do you have left? You have left with an orange circle, right? Because it's the only thing that's still in the numerator. In the bottom one, the squares cancel. And it looks like the smiley face is going to be the only thing that's left. So what must have been the question mark? It must have been, a peach or so donut thing, so that they were able to cancel. Seems weird, I know, but keep those concepts in mind, and you flip back to those pictures at any time, because now we're going to start doing it with some actual numbers here. What we're going to be putting in our fractions, so let me actually go back to this. What we're going to be putting in our fractions in these problems are things called conversion factors. It's a word, maybe you haven't heard of it before, but you've used them, you understand them. So the idea that $1 and 4 quarters and 10 dimes and 20 nickels all stand for the same amount of money. So that's where you get the same quantity, right? But expressed in different ways, right? All of those stand for $1, but they're just expressed differently. Think of the next line, 1 meter, 100 centimeters, 1,000 millimeters. Those are all the exact same length, but because they have different units and different numbers, they may look different, but they actually stand for the same quantity of length. And this last one, remember, this is a brand new one that we just learned a few videos ago, that 1 mole is this term that's equal to 6.022 times 10 to the 23rd particles. Remember, it's just like the word dozen, how a dozen stands for 12. Well, the word mole stands for 6.022 times 10 to the 23rd. So what you'll always see with conversion factors is that there's always equal signs. And those equal signs are there because they tell you these things are all equal to each other. It's weird because they may be equal to each other, but there's different numbers. Okay? So look at this graphic here. You can see 1 meter on the left and 100 centimeters on the right. Don't those stand for the exact same amount of length? Sure. And notice that as you have a smaller number, the unit is larger. What do I mean by that? Well, a meter is much larger than a centimeter, right? So the larger the number, the smaller the unit, and vice versa, right? The larger the number, the smaller the unit. Because in a conversion factor, we take two quantities that were on equal side, that are on either side of an equal sign, like 1 meter is equal to 100 centimeters, and we put it into a fraction. And it actually doesn't matter which side we put on top and which side we put on bottom, because all conversion factors really equal 1. It seems weird. How can 1 over 100 equal 1? Well, in science, numbers have units. And so 1 over 100 doesn't equal 1. But 1 meter over 100 centimeters, those are the same quantities of length. And as we know, when we have the same thing on the top and the bottom of a fraction, if we have the same quantity, we can cancel those guys out. So what does that mean? And this is very strange. When a measurement is multiplied by a conversion factor, the numerical value is generally changed, but the actual size of the quantity measured remains the same, since really it was only multiplied by 1. The next learning objective that we're going to look at is actually using this concept of conversion factors, and we're going to be doing an awful lot of math in the next few videos. So make sure you have your calculator handy before we move on to the second learning objective, which is actually using dimensional analysis.